Hi guys, and welcome to the next installment of the Mastering Python course. Today we're going to explore a useful data structure that might remind you of something that you've seen in math class. But don't worry, it's not as scary as it sounds. We're going to look at sets today. A set in Python is a collection of unique items. Think of it like a bag where you can put different items in, but you can't put in the same item twice. In a nutshell, sets in Python are unordered collections of unique items. Now, there are many reasons for using sets, and we're going to look at a lot of them. As always, Python has many ways of creating sets, and that's where we're going to start today. So buckle up, power up VS Code, and let's get started. We can create a set using curly braces. Here, for example, we're initializing a set with three fruits: apple, banana, and cherry. Now, this creates a set with these three fruit names. Notice how we use curly braces and not square brackets like we do with lists or parentheses as we do with tuples. Seeing what we know about lists and tuples, you might think an empty set would simply be empty curly braces. But that actually creates an empty dictionary, which we'll look at in the next lecture. Now, to create an empty set, we use the set constructor. We can also use the set constructor to create sets with initial values. These can be from lists, tuples, or even strings. Here are a few examples of creating sets with a list, with a tuple, or even with a string. One of the cool things about sets is that they automatically remove duplicates. You can see in this example that all duplicate numbers have been removed and we're left with 1, 2, 3, 4, 5 as unique values. This can be really useful when you want to get rid of duplicate elements in a list, for example. Imagine you have a list of email addresses and you want to remove any duplicates. You could convert the list to a set, which removes the duplicates, and then back to a list. In this example, we have 4 email addresses, and we do just that. We convert the list into a set and then back to a list, and when we print it out, user@example.com is only represented once. One thing that's unique about sets is that they're unordered. If we have a set, my set, that's comprised of numbers 3, 1, 4, 1, 5, 9, and we print the set, we're not guaranteed to get these in the same order every time we run the code. So the output that I get might look completely different from the order that you get. However, one thing that we both have in common is that the number 1 only occurs once since all duplicates are removed. And you can also notice how the order isn't the same as we entered it. And that's because sets don't care about order. Now, not caring about order has a few implications. First of all, you can't access elements by index as we can do with lists and tuples. And when you iterate over a set, the order might be different each time, so you can't guarantee a set order. The order you see when you print a set might change between different runs of your program. But the main advantage of sets is they only store unique elements. If you try to add a duplicate, it simply won't be added, as we'll see in a moment. But as always, there's a catch. Only hashable elements can be added to a set. This means only immutable types like numbers, strings, and tuples can be elements of a set, but mutable types like lists can't be. In this example, the invalid set contains a list and therefore is not a valid set. Sets themselves, however, are mutable, which means we can add and remove elements after creating the set. To add a single element to a set, we use the add method. Let's start with a simple set 1, 2, 3. And we use the add method to add value 4 to the set. When we print it out, we get 1, 2, 3, 4. If we add the number 2 to the set, nothing changes, as 2 is already a member of the set. This is really important to remember that sets only comprise unique values. To add multiple elements at once, we use the update method. This method can take an iterable like a list or another set or a tuple and add all the individual elements to the set. Here's an example. We start with my set 1, 2, 3 and we update it with the list 3, 4, 5. Now when we print it, the number 3 doesn't get added again because it's already contained in the set. After that, we update with another set and a list in the same instruction. And this is a really cool feature of update, that you can also add multiple iterables in one command. We can of course also remove elements from sets. The remove method lets you take out specific elements. You specify the element that you'd like to delete, and remove will automatically eject it from the set. Here's a quick example. We use the remove method to delete banana from the set fruit basket, probably because we had a banana for breakfast. Now, if you try to remove an element that's not in the set, for example a mango, Python is going to raise a key error, like we've seen before. There's a much safer way to remove elements without worrying about errors, and that's the discard method. The syntax of the discard method is the same as remove. Now, the only difference is that if the element does not exist in the set, discard doesn't raise an error. Let's do the same thing as before, but this time with the discard method. You see? Now you use discard when you're not sure if an element is in the set and you don't want your program to crash. We also have the pop method that removes and returns an arbitrary element of the set. Now the element removed by pop is unpredictable, and you use this method when you don't care which element is removed, but you just want a random element. Now where things get really exciting about sets are set operations, and Python has a range of operators and methods for operating with sets. The first one is the union method or union operator, which combines elements from two or more sets, creating a new set with all unique elements. The intersection method or intersection operator finds common elements between sets, and you use this when you want to find items that exist in all sets. The difference method or difference operator minus gives you elements in one, but not in another set. So for this method, the order that you apply the difference in is really important, because set 1 minus set 2 is different from set 2 minus 1. Does this remind you of math class yet in Venn diagrams? Well, in that case, we also have the symmetric difference or the hat operator. The symmetric difference returns elements that are in either set, but not in both. Like imagine listing all the music albums that either you or your friend have, but not the ones that you both have. And that's also a great way to discover new music. Let's have a look at the operations in action. We start by defining two sets, 1, 2, 3, 4 and 3, 4, 5, 6. What do you think the different set operations will output? Take a moment, pause the video and predict the output. Is this what you expected? So the union method returns 1, 2, 3, 4, 5 after combining the two sets. The intersection between the two sets are elements 3 and 4, while the difference of set 1 minus set 2 was 1 and 2. Now finally the symmetric difference was 1, 2 and 5, 6. How about that? Now here's something cool. Those methods can work with multiple sets at once. Imagine you have 3 sets and you want to get the union between all 3. Here's how to do it. We have our 3 sets, our result is set 1 and the union of set 1 with set 2 and set 3. The output 1, 2, 3, 4, 5, 6, 7. Sets and these operations are super useful in real-world programming. You might use them to find common friends between users in a social network, or compare inventory between stores, or filter unique data in data analyses. The use of sets is really unlimited and you'll come across them time and time again. Okay, time to put into practice what you've learned. Now in this little exercise you have 3 sets. One representing genres of movies a user likes, one representing genres of movies that are currently available, and one representing genres of movies watched by friends. Now what you have to do is find and print the genres of movies that the user likes and that are available. Secondly, find and print the genres that are available but that the user has not shown interest in, so potentially new genres to explore. And then find and print genres that are liked by both the user and their friends. As a bonus, you can also suggest a new genre to explore by finding a genre that is available, liked by friends, but not yet liked by the user. Good luck. Pause the video, have a go at it, and when you're done, compare it to the solution. Okay, so here's a possible solution. We start with our 3 sets, user likes, available movies, and friend likes. To find the genres the user likes and that are available, we use the intersect method. In this case, intersection between user likes and available movies. To find the genres available but not liked by the user, we simply use the difference. We subtract the user likes from the available movies. To get the genres liked by both the user and the friends, again you guessed it, we're using the intersect method to find which ones they have in common. And the answer to the bonus question is a combination of 2 of these methods. First, we take the intersect between the available movies and the friends likes, and then we subtract the user likes from this to get a recommendation of new genres to explore. Now in set theory, we often want to know if one set is contained within another, or if one contains another set. And this is where subsets and supersets come in handy. Now Python gives us an easy way to check these relationships. For this we have the isSubset and isSuperset methods. It's like asking, hey, is everything in this set also in that other set? Or does this set contain everything that other set has? In this example we have 3 sets, fruit, citrus and fruit basket. We can check whether fruits and citrus are subsets of fruit basket, or if fruit basket is the superset. In this example, both fruits and citrus are subsets of fruit baskets because their values are contained within fruit basket. And fruit basket is the superset of both fruits and citrus because it contains both of their elements. Let's go back to our example of building a game where player collects items. You could use sets to represent item collections and check if a player has all the items needed for a special power-up. Here we have the required items, so they need a sword, a shield and a potion. And we have the items that the player has, a sword, a shield, a potion, a map and gold. With the simple if statement, we can see if the required items are a subset of the player's item. And if they are, then the player has all the requirements and he can use a special power-up. If not, they can't. One further thing in set theory is when two sets are considered disjoint. They are disjoint if they have no elements in common. And Python also provides a handy method to check for this, is disjoint. Let's look at an example. Here we have three lists on which we can check whether they share elements. We have 1, 2, 3, 4, 5, 6 and 3, 4, 5. Now if we check whether they are disjoint, whether they don't share any elements, we can see that 1 and 2 are disjoint, they don't have any elements in common, whereas sets 1 and 3 they do share the number 3, so they aren't disjoint. The is disjoint method is particularly useful in algorithm design. For instance, you might use it to check if two groups of items are completely separate. Now finally, let's have a quick look at sets in data analyses. Sets are great for quickly removing duplicate values, as we've seen, and for checking unique values. Let's say you have a list of customer IDs and you want to know how many unique customers you have. You can very quickly convert your list into a set and get the length of the set. In this case, it will output, we have 5 unique customers. You could also analyze sales data to get statistics on unique products sold, as in this case we have a list of tuples, and we convert this list of tuples into a set. And we use tuple comprehension and create a set to get our unique products. Again, in this case we print out the unique products sold are apple, banana and cherry. Okay, as a final exercise, you're going to do some set-based inventory management. Imagine you're managing the inventory of a store. You have a set representing items currently in stock, items that need to be reordered, and items that are on sale. For this exercise, I'd like you to find and print the items that are in stock and also on sale. Find and print the items that need to be reordered but are not on sale. Check if all items on sale are currently in stock and print the result. And finally, remove items from the reorder list that are already in stock and print the updated reorder list. Okay, quite a bit to take in. Pause the video, have a go at this, and when you're done, let's compare answers. So here's how I would have done it. We have our 3 sets in stock to reorder on sale. To get the items that are in stock and on sale, we use the intersect, so the AND gives away the intersect. For items to reorder but not on sale, we use the difference operator to remove one set from another. If we want to see if all sale items are in stock, we can see if the on sale items are a subset of in stock. And if they are, then we know all the items are in stock. And finally, to update the reorder list, we take away what's in stock from the reorder list. And it's as straightforward as that. Again, a few very simple set operations. If you got this right, well done. If not, don't worry about it. Have another look at some of these set operators. It's all part of the learning process. And there we are, sets. I hope this didn't bring back any traumatic experience from math class, but it wasn't that difficult, was it? Next time, we're going to look at dictionaries to conclude our little mini-series on data structures. Until then, happy coding.